We've all been there. That familiar turn of the key, the satisfying rumble as the engine roars to life, and you're ready for the day. But have you ever stopped to think about what's actually happening under the hood during those few seconds? It's more than just magic, you know. It's a symphony of engineering, a carefully orchestrated dance of electrical and mechanical components working together to get you moving. This is the automotive starting system in action. It's the unsung hero of every drive, reliably kicking things off without complaint, hopefully. But like any good hero, it deserves a closer look. Understanding the basics of this system isn't just for mechanics, it's empowering knowledge for any driver. Knowing how your car starts can help you troubleshoot problems, make informed decisions about repairs, and even appreciate the ingenuity behind this everyday miracle. So, buckle up as we delve into the fascinating world of automotive starting systems. Let's unravel the mystery together and shed some light on this essential part of your vehicle. The journey begins with the car battery, the heart of the starting system. This powerful component stores electrical energy and provides the necessary power to start the engine. When you turn the key, the battery sends a high current to the starter motor, initiating the process. The starter motor, a small but mighty device, converts electrical energy from the battery into mechanical energy. This mechanical energy is then used to turn the engine's flywheel, which in turn starts the engine. The flywheel is a crucial component that helps to maintain the engine's momentum once it starts running. The ignition switch, which you turn with your key, is the gateway to this entire process. It sends a signal to the battery to release its stored energy, setting off a chain reaction that brings the engine to life. Spark plugs play a vital role as well. They ignite the air-fuel mixture in the engine cylinders, creating the combustion needed to power the engine. This combustion process is what ultimately drives the pistons, turning the crankshaft and keeping the engine running. The crankshaft connected to the pistons converts the up and down motion of the pistons into rotational motion, which powers the vehicle. The alternator then takes over, recharging the battery and powering the car's electrical systems while the engine is running. All these components work in perfect harmony, ensuring that your car starts and runs smoothly every time. Regular maintenance and understanding of these components can help prevent starting issues and extend the life of your vehicle. With this knowledge, you can approach car troubles with confidence, knowing that you have a deeper understanding of what's happening under the hood. So next time you turn the key, take a moment to appreciate the intricate dance of engineering that gets you on your way. It's more than just a turn of the key. It's a marvel of modern engineering. And as you drive, remember that every journey begins with that simple yet complex act of starting the engine. It's a reminder of the incredible technology that powers our daily lives, often unnoticed, but always reliable. So the next time you start your car, think about the symphony of components working together and appreciate the marvel of engineering that makes it all possible. Because in the end, there's always more than meets the eye. Thank you for joining us on this journey through the automotive starting system. Stay curious and keep exploring the wonders of engineering. In essence, the automotive starting system is the engine's kickstarter. It's the mechanism responsible for cranking the engine to a speed sufficient for the combustion cycle to begin. Just like we need a little push to start running, the engine needs a forceful spin to get going. This system acts as the muscle, providing the initial momentum for the engine to take over and run on its own. At the heart of this system lies the battery, the powerhouse of the operation. It stores chemical energy, ready to be unleashed as electrical energy on demand. Think of it as the reservoir of power, always charged and prepared to deliver the initial jolt needed to get things moving. This electrical energy is the lifeblood of the starting system, flowing through wires and components, bringing them to life with a jolt. Section 4. Ignition, the spark that starts it all. Next, we have the ignition switch, the command center of the starting process. Turning the key engages the ignition switch, completing a circuit that sets the entire system in motion. This simple action acts as a trigger, unleashing the stored energy and directing it to where it's needed most. It's like flipping a switch, activating a chain reaction that culminates in the engine roaring to life. Section 5. The starter motor, from electrical to mechanical. The starter motor is where the real magic happens, the transformation of electrical energy into mechanical force. This electric motor receives the surge of power from the battery and uses it to rotate a small gear. This rotational force is the key to cranking the engine, giving it the initial spin it desperately needs. Section 6. Bridging the gap. The solenoid's duty. In the intricate dance of automotive engineering, every component has a role to play, and the solenoid is no exception. This small but mighty device is the unsung hero that ensures your car starts smoothly every time you turn the key or press the start button. But hold on, how does the starter motor actually engage with the engine? It's a fascinating process that involves precise timing and coordination. When you initiate the start sequence, a series of events is set into motion, all orchestrated by the solenoid. That's where the solenoid comes in. This electromechanical device is designed to handle high current and convert electrical energy into mechanical action. It acts as a bridge, a crucial link that connects the starter motor to the engine's flywheel, enabling the engine to start. This electromechanical device acts as a bridge between the starter motor and the engine's flywheel. When the ignition switch is activated, the solenoid receives an electrical signal. This signal is the solenoid's cue to spring into action, engaging a lever that pushes the starter motor's gear forward. The solenoid receives the signal from the ignition switch and uses it to engage a lever, pushing the starter motor's gear forward to mesh with the flywheel. This action is not just a simple push, it involves precise alignment and timing to ensure that the gears mesh perfectly without causing any damage. This connection is crucial, allowing the starter motor's rotational force to be transferred to the engine. The solenoid ensures that the starter motor's gear engages with the flywheel at the right moment, providing the necessary torque to turn the engine over and start the combustion process. Without the solenoid, the starter motor would be unable to engage the engine, rendering the entire starting system ineffective. Inside the solenoid, you'll find a coil of wire, a plunger, and a set of contacts. When the ignition switch sends an electrical current through the coil, it creates a magnetic field. This magnetic field pulls the plunger, which in turn moves the lever to engage the starter motor's gear with the flywheel. As the plunger moves, it also closes a set of contacts that allow a high current to flow to the starter motor. This high current is what gives the starter motor the power it needs to turn the engine over. The solenoid's ability to handle high current is essential for the starting process, as it ensures that the starter motor receives enough power to overcome the engine's initial resistance. Once the engine starts, the solenoid's job is done. The ignition switch returns to its normal position, cutting off the electrical current to the solenoid. This causes the magnetic field to collapse, allowing the plunger to return to its original position and disengage the starter motor's gear from the flywheel. Solenoids are used in a variety of vehicles, from small cars to large trucks, and even in some motorcycles. Despite the differences in size and design, the basic function of the solenoid remains the same: to act as a bridge between the starter motor and the engine, ensuring a smooth and reliable start every time. Regular maintenance and testing of the solenoid are crucial to ensure its proper functioning. A faulty solenoid can lead to starting issues, leaving you stranded when you least expect it. Mechanics use specialized tools to test the solenoid's electrical and mechanical components, ensuring that it operates correctly. If a solenoid is found to be faulty, it can be replaced relatively easily. Replacement involves disconnecting the electrical connections, removing the old solenoid, and installing a new one. This simple yet essential component plays a vital role in the overall reliability of your vehicle's starting system. So the next time you start your car, take a moment to appreciate the solenoid's duty. This small but powerful device ensures that your engine roars to life, ready to take you on your journey. The solenoid may be hidden from view, but its impact on your vehicle's performance is undeniable. Section 7. Engaging the engine flywheel and beyond. Now, let's talk about the flywheel, a large, heavy disc attached to the engine's crankshaft. The flywheel is a crucial component in the engine's operation, serving multiple purposes that ensure the engine runs smoothly and efficiently. When the starter motor spins, it rotates the flywheel, and in turn, the crankshaft. This initial rotation is essential for starting the engine, but the flywheel's role doesn't end there. This cranking action is vital because it sets the pistons in motion, drawing in the fuel-air mixture and compressing it for ignition. The flywheel helps maintain the momentum of the crankshaft, ensuring that the engine continues to run smoothly even after the initial start. It's like setting a merry-go-round in motion, gradually building up speed until the engine can take over. Once the engine is running, the flywheel continues to play a critical role by storing rotational energy and smoothing out the power delivery from the engine's cylinders. The flywheel's teeth engage with the starter motor, allowing it to spin the engine up to the necessary speed for starting. This engagement is precise and must be maintained to ensure reliable engine starts. Additionally, the flywheel helps balance the engine by reducing vibrations. As the engine's pistons fire in sequence, the flywheel absorbs some of the energy, reducing the stress on the crankshaft and other components. The flywheel also acts as an energy reservoir. During the power strokes of the engine, it stores energy, which is then released during the non-power strokes, helping to maintain a consistent engine speed. Now, let's take a closer look at two other essential components that work alongside the flywheel to keep your engine running smoothly: the timing belt and the timing chain. The timing belt or timing chain is responsible for synchronizing the rotation of the engine's camshaft and crankshaft. This synchronization ensures that the engine's valves open and close at precisely the right moments during each cylinder's intake and exhaust strokes. Proper valve timing is critical for efficient engine operation and for preventing the pistons from striking the valves. If the timing belt or chain slips or breaks, it can lead to severe engine damage and make starting the engine impossible. The condition of the timing belt or chain directly impacts the effectiveness of the starting system. A worn or damaged belt or chain can cause misfires, rough idling, or even prevent the engine from starting altogether. That's why regular inspection and maintenance are so important. Timing belts are typically made of reinforced rubber and need to be replaced at manufacturer-recommended intervals, often between 60,000 and 100,000 miles. Timing chains, on the other hand, are made of metal and generally last much longer than belts. However, they still require periodic inspection for signs of stretching or wear, and may need replacement if they become noisy or loose. In summary, timing belts are quieter and less expensive to replace, but require more frequent maintenance. Timing chains are more durable and can last the lifetime of the engine, but are costlier to replace if they do wear out. Neglecting the timing belt or chain can lead to catastrophic engine failure, so always follow your vehicle's maintenance schedule and consult a professional mechanic if you notice any unusual noises or performance issues. In modern hybrid vehicles, the flywheel's role has evolved even further. It can be used to store kinetic energy during braking, which is then used to assist the engine during acceleration, improving fuel efficiency and reducing emissions. Even in electric vehicles, the concept of a flywheel is used in regenerative braking systems, where the energy from braking is captured and stored for later use, enhancing the vehicle's overall efficiency. Proper maintenance of the flywheel is essential for the longevity and performance of the engine. Regular inspections can help identify wear and tear, ensuring that the flywheel continues to function effectively. Mechanics often check the flywheel for signs of damage, such as cracks or worn teeth, which can affect its performance. Replacing a damaged flywheel can prevent more serious engine issues down the line. Flywheels come in various sizes and designs, depending on the type of engine and its specific requirements. From small engines in motorcycles to large industrial engines, the flywheel's fundamental role remains the same. Historically, flywheels have been used in various types of machinery, not just engines. They have been a critical component in everything from steam engines to windmills, showcasing their versatility and importance in mechanical systems. Innovations in flywheel technology continue to emerge, with advancements in materials and design improving their efficiency and performance. These innovations ensure that flywheels remain a vital part of modern engineering. As we look to the future, the flywheel's role in energy storage and management will likely expand, playing a key part in sustainable and efficient energy systems. From traditional engines to cutting-edge renewable energy solutions, the flywheel's journey is far from over.